I'm not sure if you noticed it in the last lectures. With our working application, if I add servers and blueprints, something changed. A new server down here in the blueprint, as well as the paragraph right at the top, no longer has a blue color. Now it was colored blue before, because in the app component CSS file, we defined that paragraphs should have a blue text color. But both paragraphs were moved. They are no longer part of our app component here. The first paragraph is part of the cockpit, and the second paragraph, well, that is inside of our server element. But isn't that strange? Here, on this CSS definition, we just say paragraph. So it should affect all paragraphs in our whole app. Now you might say, well, no, it's in the app component CSS file, so clearly it only belongs to this template. But is that so clear? Because the way CSS works, it doesn't really care in which CSS file you define a rule, it simply is applied to the whole document normally. So this actually is a behavior enforced by Angular, which is not the default behavior of the browser. So whilst of course these CSS files have the goal of encapsulating styles for the component they belong to, this again is not a default behavior. Angular gives us this behavior. And it's a great behavior because with that, we can make sure that whichever styles we define in a CSS file will only get applied to the component they belong to. However, here of course, this means that now we would have to copy this blue color here to all our other, components where we want to use it. Well, I never wanted to use it on the cockpit anyways, but I will copy it to the server element. And if we now change this and let it reload and enter something here and add a new blueprint, now you see this is blue again. Now it's interesting if we inspect this text here in the developer tools, you see that if you have a look at the styles, clearly here we assign a blue color. But do you see that? The selector changed. Before, we had just P here, just paragraph. Now it's paragraph and then this very strange attribute, underscore ngContent dash EJO dash 2. Well, I don't know about you, but I didn't add it. You can see this attribute here on the paragraph. That is why this style gets applied here, because this style definition says make every text blue, which is in a paragraph, where the paragraph has this attribute, something which is true for the paragraph holding this specific text. Now the other paragraph we have in app cockpit, here in the div, this paragraph does have a different attribute, underscore ngContent EJO1. Down here we have EJO2. That is why the styling gets not applied to this paragraph. And all these strange attributes, which you can see all over the place here, all these strange attributes are applied to their specific elements by Angular. Angular, as I told you, enforces this style encapsulation. And it can't do that magically. So the way it does it is it simply gives the same attribute to all elements in a component. So all elements in this cockpit component have ngContent EJO1 attached to it, as you can see. And it does this for each component with different unique attribute names, EJO1 and EJO0 and EJO2. And with that, it can make sure that once it changed your style selector, it automatically adds this attribute selector to all your styles defined for a component, that these styles get only applied to elements of that component. This is how it enforces this behavior. It kind of emulates the Shadow DOM. The Shadow DOM is a technology not supported by all browsers, where each element has its kind of own, Shadow DOM behind it, where you then could assign styles to each element. But as this technology is not supported by all browsers, this is how Angular emulates it. And that is the default behavior of view encapsulation in Angular. In the last lecture, you learned how Angular encapsulates your styles. Now you can override this encapsulation though. If you go back to your code, to the server element component, you can add something to the add component decorator. It's called encapsulation, this property, and there as a value you can access view encapsulation, which needs to be imported from add Angular core, so make sure to add this import. And then you can choose between 3 modes. Emulated is the default, so you don't need to add this. None, if you add this, would make sure that if we have a look at our component again, and we inspect our server element, that now in here, we don't see these strange attributes being added to our elements. Therefore, this component now does not use view encapsulation. The other components still will use it. There you still see these attributes. But if you now define any styles for this component in the CSS file of this component, they will actually get applied globally. And I can demonstrate this by going into this CSS file, and if I change the label color, and the label is in the cockpit, not in this component, to red, yeah, now you will see the label there is overwritten. Whilst this label of course still has its custom unique attribute, it still is a label in the end. And in this server element component, we disabled encapsulation. So there our selectors aren't changed by Angular. They don't receive their unique selector. Therefore, they are enforced, they are used application-wide, also affecting other components. Might be the behavior you want. Chances are that this is not the case, but it's important to know that you can change this behavior. Now, besides none, you also could choose native, and native uses the Shadow DOM technology. This should give you the same result as before with emulated, but only in browsers which support it, which is why for most cases you want to choose emulated, but be aware that you could switch to non or native here too. So I will go back to emulated, which again you wouldn't have to add, it's the default anyways. With that, our label should no longer be red now. So that is how you can change it and how view encapsulation works. A nice tool ensuring that by default only your component receives the styles you define for it. But as you learned, it can be overwritten. Back in the application we built throughout the first lectures of this course with our cockpit and the server element component, with using output and input to pass data around our own custom property and event binding. Now in the cockpit, right now I'm using two-way data binding to get the server name and content. Now there's nothing wrong with that, but maybe we don't need to use two-way data binding. Since I only want to save or use the data at the point of time I click the button, the add server or the add server blueprint button, it would be enough to get the value of the input at this point of time. And there is a nice way we can achieve just that. So I'll duplicate this and comment out the old solution, and now I'll structure it out over a couple of lines and remove the two-way binding. There, the other option we would have is to place a local reference on that element. A local reference can be placed on any HTML element, so not only on an input element, on anything you see here in the template, and you add it with a hashtag and then a name of your choice, like for example server name, since this is, well, what this reference will hold, a reference to this element, so maybe server name input. Now important, this reference, as I just said, will hold a reference to this element. So not to the value we entered there, to the whole HTML element with all its properties. We can see this if we pass this now as an argument once we click add server on add server. Here I can pass server name input because the other important thing you need to know about references besides how to create them is that you can use them everywhere in your template, but important, only there, not inside your TypeScript code, only in the template. But we do call the method here inside the template, of course, so here we can use server name input, and that is a way how we can pass it to the TypeScript code. Because in onAddServer, we now know that we will receive the name input. You could also name it server name input. And if we log this, we can analyze what this actually means, what we actually got here. So let's save this and let our app reload. And now if I test something and enter something here and I click add server, of course, this was broken here. This is broken because we're not fetching the data correctly right now. You see, we actually got the input element itself. So this is the element we got here. That is what the local reference gives us, the element with all its properties. So here we could also output value, the value of this input, since we know that an input element has a value. And of course, this will depend on which kind of element you placed your local reference on. Not all elements have the same properties. So with this, if we try this again, you'd see we now print test because we accessed the value of this input to which we got access through the local reference. So local references, a very nice feature to get access to some elements in your template and then use that either directly in the template. You could also output server name input value here, or you can pass it on like we do to use it in the TypeScript code. A nice and handy feature. Now with that being passed, we can use it here to not only log our data to the console, but instead here, once we define or once we create the server, we could access name input value. And we should also be explicit about the type. We know that this will be a HTML input element, so we know that this value property will be there. Now the same can of course be done on the blueprint, where we can also replace this new server name with name input and then value. And with that, we can get rid of new server name. We don't need it anymore. I will comment it out so that we still have it there for reference, but the new approach now only uses this local reference. Now for this to work, we of course also need to pass this reference to our onAddBlueprint method. So these are local references.